Hello everyone and welcome. So let's talk a little bit about what is an integer and what is a float. They're both numbers. An integer is very much like what you would remember from early math. It's a whole number like 1, 2, 20, something like that. So examples of integers, and we can put them into the shell here and it'll return the value back. So we say maybe 6. If it enter, it says 6. It's blue to show that it's an integer or a recognized number and not a string. And also, 45. We can also do some simple math calculations on these. So if we do 40 plus maybe 5, it'll give us back 45. But we're going to see some different behavior here when we start dividing. So let's take 10 divided by 5, and we'll get a different type of number back. So this is 2.0. That's a float. And what's happened is Python has taken two integer values that we've given it, and it's returned a float value for us. The precision of float values, or the point after the decimal, will also change based on what kind of information you get Python here. So if we do 1 divided by 3, we're going to get a lot more precision than basically just the 10 divided by 5. You may have also noticed that earlier I had spaces between my operator and my numbers. In this most recent one I do not, but both have worked. This is really one of those things that I'm not going to weigh in a whole lot about. Everyone kind of has their own opinion about what's right and wrong. And there are some guides and things like that, but I would really just do what you feel comfortable doing. So we've talked about floats and integers now, and it seems a little redundant. Why do we have both of these types of numbers when you can do 2.0 and just use that instead? Why not just always use floats? Well, that's because floats are fairly inaccurate. You want to be careful when you use them because they do give unexpected behavior sometimes. So let's go ahead and look at that. We can do 0.2 plus 0.1. Now both of these are floats, and the answer would be pretty obvious, although we get this thing going on here, which is weird. The more in-depth answer to why this is happening is probably something for another video, but it's good to know that this isn't really a Python problem. This is more of a programming computer science thing going on here. Our number system is base 10, and computers operate a little bit differently. So for example, 1/3 in base 10 is an infinitely repeating number, and 1/10 is not, although in base 2, 1/10 is an infinitely repeating number. This sounds a bit more complicated than it really is, and we can demonstrate what's going on here in Python, so let's go ahead and do that real quick. We'll need to import decimal, which is included in the Python standard library, so you already have this on your computer, we just need to import it into the shell, and to do that we can do from decimal import everything. So this will import that entire library for us. And then we just have one more thing to do. So from the decimal module, we want to use the from float method, and we're just going to pass it a simple float, 0.1. So before we hit enter here, what exactly are we doing? Floats in Python are stored as an approximation, and when you enter some kind of float into the Python shell or the Python interpreter here, you usually get a cleaner number back, like 0.1 and nothing else. Although what this is doing here is saying, Python, I want that entire stored value that you have for the float 0.1. And there we go. So this value right here, that's the actual value of 0.1 when we entered it into the interpreter. We only see 0.1, but this is what Python is storing, is this really long decimal type number. And that's also what's causing the inaccuracies with floats. In short, this is regular expected behavior in Python. Integers are pretty much just whole numbers, and floats are like decimals, but they're a little inaccurate sometimes, so it's good to be a little bit careful about where you might use those in your program. That's about it for now, and thanks for watching.